In this video, you want to find the limit as x approaches infinity of x times e to the 1 over x minus x. If I just plug in x as x goes to infinity, we get infinity minus infinity, which is an indeterminate form. So now I have to change this algebraically so I can use L'Hopital's rule and then find the limit. So the way I'm going to do that is by factoring out e to the 1 over x. So that leaves me with x for the first term. And the second term, I want the e to the 1 over x to go away. So I'm going to multiply by e to the negative 1 over x. And then I'm going to multiply by x, because here it's just x. From there, I can use a product rule, break it up into two separate limits. And really, e to the 1 over x, you can also think of it as e to the limit as x approaches infinity 1 over x. So I guess this step is kind of optional, but basically this has to be 1 because limit as x approaches infinity of 1 over x is 0, e to the 0 is 1. So really, now we're just left with the second limit. From here, we can factor out x times e to the negative 1 over x. And the goal here is to get into L'Hopital's form, L'Hopital's rule, which is like either 0 over 0 or infinity over infinity. And by doing this, I can rewrite it so that e to the 1 over x is on the bottom. And we have x times e to the 1 over x minus 1 at the top. And before I get to L'Hopital's form, because e to the 1 over x, actually we can find the limit. We know that's just going to be e to the limit of x approaches infinity of 1 over x, which is e to 0, and that's 1. Okay, so this goes away. We're left with this one. Now I'm going to rewrite x as just 1 over x. And now we have this in indeterminate form, which is just 0 over 0. Take the derivative of the top, derivative of the bottom. The negative 1 over x squared is going to cancel, and so I'm left with e to the 1 over x, which we've done a couple times already, and we know that the limit is equal to 1.